Trouble in an electrical system will generally be one of three types: short circuits, grounded circuits, or open circuits. One must be able to recognize the different types of trouble and identify each one. An electric circuit is a path or a group of interconnected paths capable of carrying electric currents. An electric circuit exists when the source of power is attached through a pair of conductors to an electrical device, such as a lamp. Current flows from the power source through the conductors to the electrical device. To provide a measure of control, a switch is normally added. To turn the circuit off and on. To protect the circuit from damage in the event of trouble, a fuse or circuit breaker is added to the circuit. Let's take this basic circuit, enclose it properly in protective boxes and conduit, and use it to demonstrate the three most common types of circuit trouble. First, we'll examine a short circuit. A short circuit results when two bare conductors are permitted to come into contact with each other. The current no longer flows through the entire circuit. It is shunted directly from the hot conductor to the neutral conductor. When this occurs, there is only a very small amount of resistance in the circuit. According to Ohm's law, for a constant voltage, when the resistance is lowered, the flow of current goes up. This increase in current can cause heating of the wires and is the cause of many electrical fires. However, since the circuit is properly protected, the fuse or circuit breaker reacts to the excessive current and blows or trips, stopping the current flow. To correct the short, the damaged wires must be separated and, in most cases, replaced. Then, replacing the fuse or resetting the circuit breaker restores the circuit to normal operation. Now let's examine a grounded circuit. In any electrical installation, it is standard safety practice to connect the neutral conductor to the metallic structure of the power panel. In this way, the protective covering over the entire circuit, the conduit system, has the same potential as the neutral conductor. A grounded circuit results when the hot conductor is permitted to come into contact with some metallic part of the wiring system. Since the metallic parts of the wiring system are at ground potential, the current flow is shunted through the metallic structure to ground. Since the resistance of the circuit is lowered to an extremely low value, the current flow is increased until the protective device in the power panel reacts to stop the current flow. To correct this condition, it is necessary to locate the undesired grounding of the hot conductor and remove it. Then, when the protective device is reset or replaced, the circuit is restored to service. An open circuit results when one or more conductors in a circuit become broken, burned, or otherwise separated to interrupt their continuity. An open circuit prevents any flow of current in the circuit. In this example, the neutral conductor has been broken to stop the current flow. If the hot conductor was broken instead, the effect on the circuit would be the same. If any part of this circuit fails, it breaks the continuity and stops the flow of current. Replacing the defective circuit component or repairing the broken wire restores the circuit to normal operation. The fuse or circuit breaker normally does not react to an open circuit. In the field, electric circuits are generally installed in a manner that rules out a visual inspection of the wiring itself. However, to be able to correct any trouble, the electrician must be able to identify the type of malfunction that exists in the line. The correct tools and equipment will make this identification easier. The tools normally used for troubleshooting are a voltage tester and a multimeter or buzzer-type continuity tester. We will demonstrate the use of these tools to troubleshoot this familiar basic circuit. The protective device has been set off, indicating that the fault is probably a short circuit or a grounded circuit. To check the wiring safely, disconnect the conductors from the power panel. For the hot conductor, this is normally done by removing the fuse or opening the circuit breaker. However, if more than one circuit is controlled by the fuse or breaker, the conductors must be physically removed from the power connection and separated. Since a short or ground is suspected, remove the other elements of the circuit by opening the switch and removing the bulb. To check for the suspected condition, use either the buzzer-type continuity checker or the ohm meter portion of the multimeter. When the meter is applied to one of the conductors and the metallic cover of the fuse box, it gives a high resistance reading, which means there is no continuity. Next, the meter is applied to the other conductor and the ground point. As it indicates no continuity, neither conductor is grounded, eliminating this as the source of trouble. When the meter leads are placed across the two conductors, the meter registers very low resistance, indicating that the two conductors are in contact with each other, a short circuit. Since the switch is open, the circuit problem must be in the length of conduit from the power source to the switch. To verify this, move the meter to the connections at the switch and check with the meter on both sides of the switch. On this side of the switch, the circuit indicates high resistance or no continuity. But on this side, the meter indicates the short. So the trouble has been identified and located. The short circuit is removed, and the circuit is checked once again with the ohm meter. This time, the circuit checks out properly. So it is now safe to replace the fuse, and the circuit is placed back in service. This time, let's examine another case where we come on the trouble site to find a blown fuse. Once again, to deal with the circuit safely, remove the wires from the power source. Remove the other elements in the circuit by opening the switch and removing the bulb. This time, instead of using a multimeter, let's use a buzzer-type continuity tester. This tester is simply a small door buzzer and a dry cell battery. When the two test leads are brought together, the current activates the buzzer and it makes a sound. Thus, when the leads are placed on a circuit under test, no sound means no continuity, while this sound means continuity. First, checking between the two conductors indicates that there is no short circuit in the first section of the circuit. And there is no continuity between the hot conductor and ground in this section. However, between the hot conductor and ground in the second section, there is continuity. Since this is the last section, the testing is complete. In a longer circuit, the diagnosis would be confirmed by checking the next connection. The ground is removed, and the circuit is retested at the trouble point, and all connections are restored. The light and fuse are replaced, and when the switch is turned on, the circuit is back in service. Perhaps the most common trouble in wiring circuits is an open circuit. In lighting circuits, the most common fault is a burned-out bulb. But sometimes the trouble may be caused by a loose or broken wire, requiring troubleshooting to locate it. Since the fuse did not blow, we suspect that the problem is an open circuit. Inspection or replacement of the light bulb reveals that it is good. The voltage tester will be valuable for this test. Checking at the source, there is voltage at the fuse box. Moving to the switch box, voltage is still present. Checking at the far side of the switch reveals voltage, so the switch is good. The final checkpoint is at the fixture box. At this point, there is no voltage. The trouble has been traced to this section of conduit. However, continuing a step farther can determine which conductor is defective. A check between the hot conductor and ground indicates 110 volts, which proves that the hot conductor is continuous. So the open circuit must be in the neutral conductor. Replacing the defective section of neutral conductor restores the service. For simplicity, we've been working with a very basic circuit. In practice, circuits usually involve several junction boxes and one or more branch circuits, all fed by the same fuse or circuit breaker. However, the procedure for troubleshooting such circuits is the same. Beginning at the power source, isolate one section of the circuit at a time until the trouble is located. Trouble in electric circuits can be classified into three general types: short circuits, grounded circuits, and open circuits. But regardless of the type of trouble, it can be found rapidly and safely by following sound troubleshooting procedures. Make an operational check of the circuit. Conduct a thorough visual inspection. Study the schematic diagram if it is available. Analyze the information that has been obtained. Locate the actual position of the trouble. Perform the repair.